The project we chose was a new construction of a multipurpose hall covering a footprint of 831 meters square at Kampung Sawak, Port Dickson. The site was previously a palm oil plantation, which is the primary cause of the current geotechnical instability, which are soft clay and high water table level.
The project site consists mainly of soft clay soil with high natural moisture content and a high groundwater table. This condition reduces the soil bearing capacity and shear strength, making the ground unstable for construction. In addition, the presence of decomposed organic matters from previous agriculture activity further weakens the soil structure. Similar case studies on soft clay sites in Malaysia have reported excessive settlement, differential settlement and construction difficulty due to poor subgrade condition. This finding highlight the major geotechnical challenge that must be considered before any development can proceed.
The proposed solution to overcome the geotechnical problem at the site is by dewatering system and rough foundation. Dewatering system reduces the high water table to create a safe and stable environment for excavation, whereas rough foundation prevents uneven settlement by distributing the load evenly. Moreover, the rough foundation allows the creation of an underground basement level which can be utilized as an underground parking to maximize the limited site area.
Excavation value. Our site has very weak medicine. During excavation, removing the soil weight causes a severe stress imbalance. This triggers a plastic shear failure, forcing the surrounding mud to squeeze inward and a bottom to push upward. Second one, post-construction. The heavy building load risks exceeding the soil bearing capacity. Additionally, the watering lowers water pressure, spiking the effective stress. This causes rapid and even settlement across the building footprint. Structural impact. This uneven soil support force the superstructure to redistribute its load. Over time, the angular distortion will exceed the critical 1/500 per limit, introducing several tensile strengths that will crack our columns and walls.
To handle the software at our site, we designed a smart foundation system. We are combining a sheet pile wall, dewatering pumps, and concrete rough foundation. By building an underground basement, we use the floating foundation principle, where removing the heavy clay offsets the building's weight to stop the ground from settling. Finally, we are using wireless sensor to monitor soil and water levels in real time, making sure the excavation stay completely safe.
So 34-hour dewatering causes clay settlement under nearby house, cloud, noise and acidic wastewater. So I will give a 4 solution. First, steel sheet pile to block water movement and stop the nearby house from cracking. Second, water treatment system to automatically neutralize the acidic water before the pumping it out. Third, retention tank to store excess water during heavy rain and prevent flash flood. Lastly, acoustic enclosure to cover the pump and block loud noise at the night.